Okay, here we go. This is Slope, Part 1, start of the new unit. But with some, familiar stuff, which is a linear function. That's a function where the data points lie on a line. And two examples are shown below. So the cost for a number of textbooks, or the liters of fuel used in driving. Wow, went way too far. For the first function, the independent variable is the number of texts. And what depends on that? The cost depends on the number of texts. For the second function, the independent variable is time. And what depends on that? The amount of fuel depends on how long we've been driving. For a linear relation, the rate of change is the change in the dependent variable over the change in the independent variable, which we have specified as delta y change over delta x. If the axis is not labeled with a variable, the most common variables to use are x and y. Determine the rate of change of each of the above functions and provide units with your answer. So we need a change in cost depending on the number of texts. So one way to do that is to say, well, the cost is 40 and the cost here is 35, so that's a delta y. It's a change in y of $5 for 150, or sorry, to go from 150 to 200, so it's a change of up $5 for 50 more texts. So $5 for 50 texts. And what we'll often try and do then is get a unit rate. So 5 divided by 50 is 0.1. So $0.1 per text. So that's a unit rate, since on the bottom we have one text. Here we have a change, so we go from 60 to 50, we go down 10 liters of fuel in 2 hours. Minus 10 liters in 2 hours, which would be down 5 liters per hour. And again, this would be a unit rate, and we have units, right? I mean, there is meaning to the slope of these graphs since they have units associated with them. For the first function, as the independent variable increases, the dependent variable increases. And the rate of change is a positive number. In the second function, as the independent variable increases, the dependent variable, let's just take a quick look. So as the independent variable, as time marches on, the amount of fuel goes down. The dependent variable decreases, and the rate of change is a negative number, right? We are down 5 liters per hour. The change in the dependent variable is called the rise, and the change in the independent variable is called the run. And another name for the rate of change of a linear function is the slope of the line. So the slope of a line is rate over rate of change, which was the change in the independent over the change in the dependent, or rise over run. And here's a couple of examples. So the change in the dependent variable, that's delta y, the rise. So we can see that we're going up. And the change in the independent variable is the run. And here we can see a rise, which is negative. It's going down. So we have a negative rise. So in other words, slope of a line is the rate of change, is the change in the dependent variable over the change in the independent variable, which is defined as delta y, change in dependent over delta x, change independent, or rise over run. More simply, we say the slope is the rise over the run, and we use the letter m to denote the slope of a line, so we say m is equal to rise over run. Note, when finding the slope or steepness of physical objects, ladders, roofs, ramps, etc., we always use a positive slope because the direction in which you are viewing the object can change. So what is the slope or steepness of the ramp shown below? Slope is rise over run. Remember the secret to math. You got a formula, use it. Slope is a rise of 4 over a run of 17. And then if we needed to, we could express that as a decimal, or we would leave it as a reduced fraction. More properly, leave it as a reduced fraction. What is the roof of a house shown as symmetrical? What is the slope or steepness of the roof? So what we don't have a run of 18, we have a run of 9. So slope is rise over run, which is 6 over 9. And that reduces to 2 over 3. And generally speaking, that's how we'll leave our slopes, as reduced fractions. A 5-meter ladder leans against a building and reaches up a height of 4 meters as shown. What is the slope of the ladder? Slope is rise over run, which is 4 over 5, and that's where we leave it. And again, we may be asked to express it as a decimal, in which case we would convert it to a decimal, which in this case is 0.8. Generally speaking, though, we leave slopes as fractions. For slopes of a line on a Cartesian plane, we need to distinguish between positive and negative slopes. To calculate the slope of the line on a Cartesian plane, do the following steps. Start at the left endpoint, so we're going to go from left to right, but before we do that, of course, slope is rise over 1, so we're going to go up or down. So start at the left endpoint and draw a vertical segment until you're at the same height as the right endpoint. Okay, so start down here, go up, or again, starting at the left endpoint, go down. From here, draw a horizontal segment until you reach the right endpoint of the original line. Find the rise. If you went up, the rise is positive, and if you went down, the rise is negative. The run, since you're going from left to right, is always positive. Okay, so here we're just doing a counting thing. 1, 2, 3, up 3, 1, 2, 3, 4, 5, 6, 7, right 7. Here we're going 1, 2, 3, 4, down 4, and 1, 2, 3, 4, 5, 6, right 6. This will always be positive since we'll always be going to the right. Write the slope ratio. Slope is rise over run. They gave me the formula here, so I'm just going to go with 3 over 7. And here m is equal to negative 4 over 6, which we will reduce to negative 2/3. All of the line segments you've seen so far were oblique, which means on an angle. Oblique line segments are line segments that are not horizontal or vertical. From question 4, you saw the slope of an oblique line segment could be positive or negative. Without doing any calculating, how can you determine just by looking at an oblique line segment whether the slope will be positive or negative? So we're asking, just looking at this segment, how can you tell if it's positive or negative? And think about what we've done. If we're always going to the right, then the run will always be positive, so it's up to the rise to determine the sign. So an oblique line will have a positive slope if it rises to the right. So in other words, if it goes up. So I'm not going to use rises because that's what we're already using. So let's say we'll have a positive slope if it goes to the right. And an oblique line will have a negative slope if it goes down to the right. And conversely, or in addition to that, if for some reason you're looking at the line to the left, a positive slope will go down to the left because it will have a negative rise and a negative run, and a negative divided by a negative is positive. And if again for some reason we're looking to the left on this line will go up 4 and left 6, which would be a positive over a negative, also giving you that negative slope. Easier to think of though is just saying, what does the line do as we're going from left to right? Does it rise? Does it go up to the right, or does it go down as we're going to the right? Horizontal line segment. This rise, well, there is no rise. We have a rise of 0. The run is 1, 2, 3, 4, 5, 6, 7. Slope is rise over run, which is 0 over 7, which is 0. And here, so a horizontal line segment has a slope of 0 because there's no up or down. And a vertical line segment, well, we've got a rise of 1, 2, 3, so that's up 3. And the run is 0. So slope is rise over run, which is 3 over 0, and division by 0 is undefined. So we're going to say that the slope of a horizontal line is 0, and the slope of a vertical line segment is undefined. To summarize, a line segment can be oblique, horizontal, or vertical. For each line segment below, what can you say about its slope? This slope is going up to the right, it's positive. This slope, we're going down to the right, is negative. A horizontal line has a slope which is 0, and a vertical line has a slope that is undefined. State the slope of each line segment shown. Express your answer as a reduced fraction. Okay. State, no work required. So the slope, so we're going to count. We go 1, 2, 3, 4, 5, 6, 7. Up 7, 1, 2, 3. Rise of 7 over run of 3 is 7 over 3. CD, we go 1, 2 down. 1, 2, 3, 4, 5, 6. So down 2, 6, reduce, negative 1/3. Slope of EF, horizontal line is 0, and a vertical line is undefined. We don't need to do any calculations here or counting. We can just identify. For the line shown, find the slopes of AB, BC, AC, blah, blah, blah. Okay. Express your answers as reduced fraction. So AB, 1, 2, up 2, 1, 2, 3. So the slope of AB is 2 over 3. I guess I don't need the over if I'm going to use that. 2 over 3. The slope of BC, 1, 2, 1, 2, 3, 2 over 3. The slope of AC, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4 over 6, which is 2 over 3, and AD, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 6 over 9, also 2 over 3. These slopes, they are all the same. Which makes a little sense because they're all on the same line segment. So if you pick any 2 points on this line, what will be the slope of the line segment that connects these points? Slope will be 2 over 3. The points A, B, C, and D are said to be collinear, which means they lie on the same line. If the points P, Q, and R are collinear, what can be made about the conclusion of the slope of PQ? Well, they'll all be equal. So that will be equal to the slope of QR, which will be equal to the slope of PR. So the slope of any line, wherever you take it from, is a constant. Draw the line that passes through the given point, with the given slope. Label each line with its letter. So now we're going to use the definition of slope to draw points. So, or draw lines. Passing through -7, -2, -7, -2. So we're passing through this with a slope of up 5 and right 4. Okay, so we can do that. 1, 2, 3, 4, 5. 1, 2, 3, 4. Now a line is defined by 2 points, but I want to keep going. 1, 2, 3, 4, 5. 1, 2, 3, 4. Because my lines will be more accurate if I have more points on them. So what I'm going to do when I'm doing this type of exercise is draw every possible point, and then I'll draw the line. And just a note on these lines, it's not so easy drawing on a tablet. And that's A. B passes through -5, 6. -5, 1, 2, 3, 4, 5, 6. With a slope of -2/3. Now, we can think of this a number of ways, right? The way it's written, well, we can think of it as -2/3 or 2 over -3, which means from here I can say, let's go down 2 and right 3. Down 2, 1, 2, 3, and right 3. Down 2 and right 3. Down 2 and right 3. And I'm just going to really do that all the way that I can. But I can also go up 2 and left 3. Up 2, 1, 2, 3, and left 3. And now all these points should lie on a straight line, and I have every point that's on that line that I can find easily. And now we can draw the line. Whoops. And when we draw lines, there's 2 things that happen. We put arrows on both ends to indicate that this line goes on forever. And then we're labeling it with the letter that we have here. Passing through -3, -8 with a slope of 2. Okay, think of a slope of 2 as being a rise of 2 and a run of 1. So -3, let's just adjust a little bit here. -3, -8 with a slope of 2 over 1. So up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1, 2, right 1, 2, right 1, 2, 1, and there. So, it doesn't take a lot of work, but it's very handy and it makes it a lot easier to sketch. And then arrows on the ends, always arrows on the ends, because it's a line that goes on forever in both directions, and we label it. D, passing through 2, 8 with a slope of -5. Again, write that as -5 over 1. So passing through 2, 8. Go down 5. 1, 2, 3, 4, 5. Right 1. 1, 2, 3, 4, 5. Right 1. 1, 2, 3, 4, 5. Right 1. Now, if we've drawn these correctly, then these points, we should be able to get a straight line through them. As I run off the tablet. And I'm going to label this one down here D. I should use different colors, but oh well. Passing through 5, 4 with a slope of 0. Passing through 5, 4. Slope of 0 we know is a horizontal line. So we draw a horizontal line. And arrows on both ends. And label E. And lastly, passing through 7, negative 4, 7, negative 4, with an undefined slope. Undefined slope tells us this is a vertical line. So we draw a vertical line and label it where we can, and that is F. So what do? We find the point. We use the definition of slope. We go both ways if we can, right? When we have a slope of negative 2/3, we go down 2, right 3, or we go up 2, left 3. When we have lines like negative 3, negative 8, these were all kind of on the ends, okay? But I could take a slope of negative 5, or sorry, 5, negative 4. Is that the first one? Negative 7, negative 2. Yeah, I wasn't able to go this way. But you could also look at this slope as being negative 5 over negative 4. So if I could have gone down 5 and left 4. So let's say starting at this point, 1, 2, 3, 4, 5 down, 1, 2, 3, and 4 to the left. Draw the line that passes through 0, 0 with slope 1/3. This time we use different colors, so let's try this. The slope 1/3. Go up 1, right 3. Go up 1, right 3. Okay, I can't do that anymore, but I can go down 1, left 3, down 1, left 3, down 1, left 3. And now I've put every point that I can that's on the grid. If I go down 1 and left 3, I'll be off here somewhere. And let's draw the line. And arrows on both ends, so that's purple. Let's use red. The slope of 1. Go up 1 over 1. Up 1 over 1. Up 1 over 1. And so on. And let's do the same thing the other way, starting at 0, 0. Go down 1, left 1. Down 1, left 1. Down 1, left 1. And so on. And that makes it fairly easy to draw. And what I want to see when you're doing this stuff is I want to see a lot of points. And, you know, maybe your line is a little shaky, but if your points are good, then I'll know what you meant. Slope of 5 halves. 5 over 2. Go up 5, right 2. Now you notice I can't go up 5 again, but I can go down 5 and left 2. And we can draw that line. And lastly in green, a slope of 4. Go up 4 over 1, up 4 over 1. Okay, that's not good enough for me, so I'm going to go down 4, left 1, down 4, left 1. And we'll draw the green line with a slope of 4. Since all the slopes are positive, as we go from left to right, the line goes up. As the size of the slope of the line increases, so what do we have? 1/3. 1, 5 over 2, 4. You notice the line gets steeper. You also notice here that as we go from right to left, we go down. Where's my thinness? My line of thinness. Draw the line that passes through 0, 0 with a slope of negative 1/3. Okay. Negative 1/3. Now remember, negative 1/3 can be looked at as negative 1 over 3 and can also be looked at as 1 over negative 3. So we're going through 0, 0. And we can look at it as, so we'll do these first. Go down 1, right 3. Down 1, right 3. Down 1, right 3. But you can also go up 1, left 3. Up 1, left 3. Right, and now we can draw this line as best we can. And as I said, I can be forgiving as long as I see the points are correct. But you can use the edge of your battery case. So slope of -1, go down 1, right 1, down 1, right 1. These guys are pretty. Running out of tablet. And go, and from 0, 0, go up. Up 1 and left 1. So up being a positive direction and left being negative. We need one positive, one negative if we have a negative slope. And -5 halves. Starting at 0, 0. Wow, I didn't do a good job of down 5. 1, 2, 3, 4, 5. Right 2. And we can also go up 5, left 2. And there's a nice yellow line. And the green line, -4. Go down 4, right 1. Down 4, right 1. Oops, I'm sitting near the bottom of the tablet. Go up 4, left 1. Go up and left. And draw the line, the shaky, shaky line. So since all the slopes are negative, as we go from left to right, the line goes down. But remember, we can also go up to the left. So we go down to the right or up to the left. As the size of the slope of the line increases, the line gets steeper again. Bigger slope, steeper line. The line shown intersects the x-axis and the y-axis. The x-coordinate of the point of intersection of the line and the x-axis is called the x-intercept. So this x value here. State the coordinates of the x-intercept and mark it with a dot on the graph. So the x-intercept is simply the number 6. It's the x-coordinate. So I'm going to say here, let's state the value. The point is 6, 0. So we would say the line intersects the x-axis at the point 6, 0, but the x-intercept, that is a number, which is just the number 6. The y-intercept is the value -4. And the point at which the line intersects the y-axis is 0, -4. -4. So intercepts are just strictly numbers, but it's associated with a point. And the point of intersection is 6, 0. And the point is 0, -4, and we want to use these points to find the slope, so we just 1, 2, 3, 4, go up 4, go right 6. So slope is rise, which is +4, over run, which is +6, and reduced fraction, 2/3. Draw a line with x-intercept 7 and y-intercept, whoops, wrong line. Draw a line with x-intercept 7 and y-intercept 5. What's the slope of this line? Well, let's draw the line. And it's a straight line. I'm going to try and draw that. There we go, as straight as I can. But we're going to use these 2 points. So we go 1, 2, 3, 4, down 5, right 7. So So slope is rise over run, down 5, right 7, and that doesn't reduce, right? So it's just negative 5 over 7. State whether each line has a positive slope, negative slope, zero slope, or undefined slope. So a line with a negative x-intercept and a positive y-intercept. So let's just try that out. So a negative x-intercept and a positive y-intercept gives us a line that goes up to the right. So this is a positive slope. A line with a negative x-intercept and a negative y-intercept. That line goes down to the right and has a negative slope. A line with no x-intercept. Well, the only way to get no x-intercept would be to go parallel to the x-axis, so that way we'll never cross it, and that has a slope of 0. And a line with no y-intercept can't cross this, so it must be a straight up and down line, and that has an undefined slope, since it's a vertical line. And it looks like we're done part 1 for slope. So I believe there may be a puzzle sheet for you to do. Puzzle sheet and the textbook homework. Okay, and we are done.